Many automotive manufacturers are dizzy as they grapple with the declining demand for electric vehicles. Ford has temporarily postponed an investment of up to $12 billion in electric vehicle production, while GM abandoned its goal of producing 500,000 electric vehicles in the first half of 2024. The main challenge stems from a scarcity of low-cost electric vehicle options, causing customers to hesitate to make the switch, especially when the average price of an electric car is around $50,000 of September. Tesla, with its groundbreaking strategy, is proving exceptional with the Model 2, a significant step forward in applying new technology, reducing production costs by up to 50%. Elon Musk has strongly committed that the Tesla Model 2, priced at $25,000, is a revolution in the affordable car manufacturing sector, with the potential for very high production capability. Why is Giga Press manufacturing technology considered crucial for the successful of Model 2? Let's find out in today's episode but before we begin, please show your support by subscribing if you haven't already, and ring your notifications bell so you won't miss out on any of our interesting videos in the future. Now, let's get started with today's content. What would it be if the Model 2 were to utilize Cybertruck technology? Elon Musk has maintained a tight-lipped stance regarding the specific features of the Model 2 production line. However, he subtly suggested that during his second interview with Sandy Munro, that discussions might revolve around incorporating advancements already introduced or planned for the Cybertruck manufacturing process. As previously leaked from sources, Tesla's $25,000 electric car, a low-cost trend-leading electric car, will be produced in Texas with an unboxed production method. This car is so small that it is expected that there will be no storage space for suitcases or luggage, and it would be ideal for casting a monolithic underbody for the Model 2 with a Giga Press. Tesla's goal is to be able to mold the entire undercarriage, including the existing front and rear castings, as well as the structural battery pack, into a single giant casting for a high-value mass-market electric car priced at $25,000. This vehicle also has a completely different design, so it is not completely suitable for a 9,000-ton pressure die casting machine. Therefore, Tesla is planning to create a new Giga Casting 2.0 using a giant Giga Press of 16,000 tons or larger. The upgraded machine will help complete the molding of the entire Model 2 frame into a single piece. This approach, according to Sandy's analysis, Monroe, uses an aluminum alloy consisting primarily of 89.5% aluminum, 8.5% silicon, and trace elements for key frame components, facing challenges during the Model 2 production. Tesla's Chief Technical Officer, Lars Moravy, acknowledged that significant improvements have been made. The new manufacturing techniques pioneered during Cybertruck development are expected to reduce factory footprint by 40%, cut costs by up to 50%, and significantly minimizes delay at each production stage. The key principle is streamlining necessary tasks at every production step. For instance, directly attaching seats to the battery pack under the floor and housing all equipment in a body shell painted in sections eliminates the need for disassembling and reassembling doors, reducing unnecessary movements and disassemblies during production. Tesla estimates that this new method will reduce manufacturing costs per vehicle by approximately $1,000. Elon Musk is placing high hopes on an electric vehicle revolution with a $25,000 price tag when implementing this production line for the Tesla Model 2. While the traditional Model 3 comprises 171 different metal pieces, the gigacasting structure of the new Model Y requires only 2 metal pieces, minimizing welds to about 1,600. This demonstrates the superior efficiency of the gigacasting process compared to traditional assembly methods. On the technological front, advances in battery technology and motors have contributed to a 75% reduction in silicon carbide usage. This means that the Tesla's next platform will be compatible with any chemical battery type. Colin Campbell, head of the powertrain system, also mentioned that the next-generation Tesla electric motor will not use any rare earth metals in its structure. Another innovation Tesla may apply to the Model 2 is a 48V low-voltage architecture, enabling the use of a wire-controlled steering system. Elon Musk suggested that this system, to be deployed in the Cybertruck, could offer greater flexibility and safety for drivers while reducing the weight of the vehicle and simplifying its mechanical structures. What is your assessment of this technology being applied to Model 2? Feel free to share all your opinions in the comments below. What makes the Giga Press a versatile tool favored in the automotive manufacturing process? In 2020, Tesla secured exclusive ownership of this large casting machine, solidifying their leading position in advanced component manufacturing technology across multiple vehicle generations. Traditional methods required labor-intensive process of drilling thousands of holes in approximately 70 steel sheets, followed by their consolidation through welding. Giga Press completely revolutionized this method by merging 70 individual components into a seamless, integral block, eliminating any imperfections. The use of Giga Press to manufacture the chassis for the Tesla Model 3 significantly reduced weight when combined with conventional welding techniques. The chassis casting process with Giga Press achieved a substantial weight reduction of up to 35% compared to traditional welding and assembly methods. The Tesla Model 3 chassis produced with Giga Press takes only 4 hours, while chassis manufacturing for other electric vehicle models typically takes up to 8 hours. This has enabled Tesla to increase production capacity and reduce manufacturing costs. The engineering team and experts at Tesla comprehend the potential advantages of this breakthrough technology, particularly in reducing production costs for the rear chassis of the Model Y by up to 40%. In the case of the Model 3, Tesla's proficient use of the Giga Press led to the removal of 600 robots from the assembly line, streamlining the entire production process. Moreover, Giga Press is poised to make a significant contribution to environmental sustainability by eliminating dozens of redundant individual parts for each vehicle, effectively reducing carbon emissions. How has Giga Press been copied by competitors? As emphasized earlier, Tesla's exclusive machinery plays a crucial role as the catalyst for cost efficiency in the company's manufacturing process. Moreover, the flexibility and performance of the Giga Press have the potential to replace numerous other robotic systems within the factory. Perfectly replacing the successful features of the Model Y does not only apply to the BZ4X. Recently, Toyota introduced its own casting machine that reduces production time to a few minutes instead of hours. The Japanese automaker applied a similar formula to Tesla's machine, and their Giga Press successfully produced the rare third of an electric vehicle using a single mold from molten aluminum. The Giga Press product from Toyota represents 83 different parts, utilizing the current 33-step method of Toyota. Toyota's Giga Press has accelerated the speed of creating complete products within 3 minutes, a significant upgrade compared to their previous time-consuming process of manufacturing various parts and subsequently bolting or welding them together. Toyota's emulation of the Giga Press is seen as a means to rapidly achieve the goal of producing 3.5 million electric vehicles annually by the end of this decade, as well as a way to save costs. Not only Toyota but Hyundai is also in the process of developing its version of the Giga Press, following in Tesla's footsteps and revolutionizing the electric vehicle production model. Similar to gigacasting, Hyundai has given a distinct name to this simulation, calling it hypercasting. On August 21, 2023, Hyundai officially filed a trademark application for its new casting method with the United States Patent and Trademark Office. Hyundai's novel approach to electric vehicle production closely resembles Tesla's Giga Press, requiring the pumping of molten aluminum alloy into the mold to reinforce the vehicle frame. However, what sets hypercasting apart is its unique ability to produce larger vehicle parts compared to conventional methods in the automotive industry. Volkswagen is not exempt from quietly incorporating Tesla's advanced technology into its operations. In 2022, Volkswagen introduced its own megacasting technology, a significant development conducive to replacing 30 individual parts, resulting in a weight reduction of around 22 pounds when combined with the company's traditional welding-based production techniques. However, it's noteworthy that Volkswagen pressing capacity in 2022 seems somewhat modest, with a maximum pressure rating of 4,400 tons and a production cycle time of only 2 minutes. We hope you'll experience the utmost relaxation after watching this video. If you do, please press the like button and join the community by subscribing to our channel. Hit the notifications bell icon to stay tuned for any fantastic videos coming your way. Your feedback and time are highly appreciated. Thank you so much for watching, and we look forward to see you soon. Until then, stay safe and enjoy.